Good morning, everyone. Welcome, and thank you for choosing this session. So, before we start, it's always tricky to be a speaker on the second day in the morning. Yeah. So, I mean, it's the good thing is that we already had some sort of chat with many of you. So I see some familiar faces, but you can also judge how much I enjoyed yesterday evening from my speech. So I hope. I need to apologize from the beginning for mistakes that I can make. So I will go to second slide. So you see the QR codes. You can scan this to ask questions, and apparently questions will pop up in the screen here, so I can answer them at the end. So while you have some time to scan, I would like to ask a couple of questions to you. Is there anyone who has never heard of the company name Trinseo? Everybody knows? Everybody is familiar with the company? Cool. Have you ever heard of my name before? Who has never heard of my name? Nice. That means after this session, you are welcome to our booth to have a cup of coffee, at least with me or with one of my colleagues. So we can explain everything on these slides in more detail with some showcase samples. Yeah. I would like to ask one more question, a little bit more technical. So if you have given a polymer right now, a plastic, which recycling method would you use? You have 10 seconds to think and answer. Mechanical recycling. Who choose mechanical recycling? Who choose chemical recycling? And who chooses dissolution? Nice. Still, mechanical and dissolution is in balance, I would say. But let's see if your answer will change after this presentation. I will ask it again later. Yeah. So let me start. Abidin Balan, I'm R&D leader in Trinseo, and my team is developing technologies, a technology platform for dissolution-based recycling. But as a company, as Trinseo, we are developing technologies for all different recycling methods. And I will briefly touch upon them as well, but I will focus mainly on dissolution-based recycling. Yeah. As a company, we have global footprint. We are active in basically thermoplastic elastomers. You can see us if you have an electronic device at your home appliances, in your pocket, these smart devices, you probably have touched one of our polymers in your lives. Yeah? So our polymers are everyday life everywhere. So you can see our current product portfolio, a broad range of materials, and we are actively investing in sustainable material solutions. So again, if one of these polymers are familiar to you, you probably touched one of our products in your life. And we can discuss about these in details if you visit our booth after the session. I will start with some facts. So I would like to thank Plastics Europe to provide these numbers and nice visuals. But you see here, this slide basically points a problem that we have. Yeah? So it's not how much plastics we are producing over year, it's how much of it is being actively recycled. And it is less than 10% every year. You see, that's basically mostly mechanically recycled portion, and it is because of, the recycled portion is so low, and that's because recycling methods right now requires only very fine selected waste feedstocks. Yeah, so that's the main thing. And if you look at the predictions by OECD. 1 billion ton by 2050. I mean, of course, we cannot be sure whether it will be realized or not, but 1 billion tons of plastics produced in a year is a huge number that we need to think about. And if the recycling portions ratios stay like this, we will have a huge problem. Uh, this is how we are trying to tackle that problem. So how we are trying to increase the recycled portion of the polymers that we are producing. And obviously we are trying to basically keep the polymers in this circle through the shortest path possible. Yeah, either mechanical recycling or dissolution-based or chemical or thermal depolymerization, we try to keep the polymers in the cycle. And you see most of the steps in the cycle we are trying to control also. Yeah. Um, so how are we trying to do this? So as I mentioned, the main problem is to access to waste feedstock with the quality that's suitable for the recycling method. And we do that via a company, Heatland, that we acquired some time ago. And basically, Heatland, via Heatland's network, we access to waste feedstock. Yeah, so I call waste as a feedstock. As a thermochemical company, this is already a new concept. Yeah. So you see here, they do some sorting and pre-treatment, and then based on which recycling method will be used, it's sent to the right facility. Mechanical recycling. So we have been recycling plastics mechanically for more than a decade. We have commercial products in the market, mechanically recycled, especially for polycarbonate. It's well over a decade we have commercial products, but also for PMMA we have mechanically recycled products. So we say if a polymer can be mechanically recycled, it should be mechanically recycled. So these recycling methods shouldn't be competing each other. They should be complementary. Depolymerization, there are only few polymers that you can very, very, very efficiently depolymerize to its monomers with very high yield and with very high purity on the monomers that you get. And PMMA is a unique example of those polymers. So we can basically go back to its monomers very efficiently. We have a depolymerization plant in Italy, and we already have some samples. As mentioned before, you can see it on our booth. This is how it goes. So we collect via Heatland, we collect waste PMMA. It goes into our depolymerization plant, and we get high purity MMA. And we also have PMMA production plants that basically recycled MMA is used in the production. So you get basically virgin, on par with virgin MMA that goes into polymerization process. So after this, let me now talk about dissolution. So dissolution-based recycling, we see that as basically second best option after mechanical recycling to bring polymers back into a value chain, yeah, at the end of life. And this, you can do that with many different methods, but how we do it is like this. Simple, we use selective solvents to extract the polymer from a mixture, selectively dissolve one type of polymer, and then the rest is physical process. We just filter and purify that polymer and recover it. There is one contribution that we made to this entire system, and that is the second step, molecular repair. So once we dissolve the polymer and it is in the solvent, we have access to its molecular structure. We have access to its backbone. And we can alter that in the way to recover broken chains, rebound them, reconnect them, or we can basically influence the molecular structure in a way that new properties are added. Yeah? So this is our main contribution to this field. And we can do that with the polymers that we are producing because we know them the best. Polycarbonate, ABS, PMMA, those polymers that we know their applications. We also know their basically formulations. So with heatland, we have access to the waste. With these technologies, we can recycle them. But because of the formulation technologies we have, we can also bring that recycled polymer back to our customers' demand. So, so if you consider about all this process and how the product carbon footprint is basically influenced by it, you can see here how each step is basically contributing. Yeah. So, in principle, from the conventional polymer production process, we decouple the process to the fossil-based virgin raw materials. And that's the big chunk of basically product carbon footprint contribution. So here, these are basically rough calculations done by our internal experts. But what is not included yet into any of these calculations is the contribution of this non-targeted fraction. So if you selectively dissolve a polymer in a mixture, the remaining part becomes free of that polymer and becomes accessible for recycling as well. So that contribution has never been included in these calculations. Here you can see basically the capabilities of these technologies. Yeah. So what we can do with dissolution-based recycling. So we can basically dissolve, purify, and then decolor. So remove all the colorants from the mixture as well, from the solution. We can remove non-polymeric parts. So metals and magnets, they can become more accessible, so more recyclable. This dissolution-based recycling is also recognized as one of the best fit for ELVR compliance, so end-of-life vehicle regulation compliance, because we can get materials from end-of-life vehicles, recycle them back, and reformulate to be used in automotive applications as well. So, and it can be used, this technology can be used to remove legacy additives that banned chemicals and so on. So, based on the requirement, based on the availability of the feedstock, based on the regulations, we can tune the tool set in the technology to achieve access to better qualities at the end. So, so far you have seen basically polycarbonate related part, and this slide basically explains what we do with ABS dissolution. Yeah, technically what we do is we rely on centrifugal separation to have a rubber part or the impact modifier part of ABS separated. We get SAN rigid part recycled and put that back into new ABS formulation. And you can see from a mixed color waste, it's also mixed with other polymers, we can get natural color ABS with properties on par with virgin ABS. So this is Trinseo's proprietary technology. You can see here basically a comparison, product carbon footprint comparison of different processes. So for any given polymer, you can have this comparison, and most of the time you will end up with the same relative product carbon footprint. So mechanical recycling pretty much in every case becomes the best in terms of product carbon footprint, but it's also, of course, depends on whether you can have access to good feedstock or not. And then the solution and chemical recycling comes, follows them. This is a showcase. So we worked together with Signify, partnered up, and we collected some street lamps, old end-of-life street lamps, and we recycled them at pilot plant, the solution-based recycling pilot plant that we have in Terneuzen in Netherlands. So, and then those recycled polycarbonates, up to 75% recycled content, mixed with 25% is virgin polycarbonate, and then basically signify 3D printed these polymers back into lampshades. So you can see some examples in our booth. We have pilot plans in Terneuzen for dissolution-based recycling. So if any of you are interested to see, please feel free to basically contact, and we can give you a tour at our pilot facility. And this is where we are. Our booth is just around the corner, so please visit us after this session. But now we are at the end of my presentation. I would like to repeat my question that I asked in the beginning. So if I give you one polymer, what would you choose? Who says mechanical recycling? And who says dissolution? Okay, more hands right now for dissolution. And who says chemical recycling still? One person? No, I have to admit this is not the right question to ask because it has missing information. So the right question would be to define a polymer type first, because recycling method, which is right, that depends on the polymer type. And based on the polymer type, different method can be the right method. Thank you very much. If you have any questions, please feel free to send it. I think I will be able to see it here. There is a question about whether or not dissolution-based recycling is suitable for fiber-reinforced materials or flame-retardant materials. So, in principle, yes. So, depending on how you set up your process, dissolution-based recycling is very well compatible with any type of fillers, because, again, the solvent is used selective to polymer itself. If you use, I mean, the dissolution-based recycling processes we are setting up will be suitable for especially fiber-reinforced materials. Yeah, so flame retardants depends if it needs to be removed. The technology can remove it, but if it doesn't need to be removed, then basically we don't need to remove it. Yeah, so this basically we can select and tune the process steps based on what's required from the final product. What are the sources you are collecting? So we can discuss this when you visit our booth. Otherwise, we will have to hire you. But we can collect any type of materials from automotive, from household appliances, from yeah, all sorts of consumer electronics as well. The part is that basically, depending on, again, how you set up the process, you can have different dissolver types to be able to accept different type of, let's say, incoming materials. So it can be already a full part coming from automotive. It can be shredded, already pre-sorted material. So again, if you visit us in our booth, we have some samples to show you. You can have a better idea about it. So if there is no chemical modification during dissolution, what would be the product quality? There is a question like that. So depends on basically how much it's degraded over its lifetime. Yeah. So when you get a waste from different applications, depending on whether it's an external application, internal application, if the polymer is protected or not, polymer properties. What you put into the system, you get out as the polymer property. So we basically do this molecular repair to be able to have consistent output regardless of the quality of the input material. So there is a question related to Taktotech. We have a partnership with Taktotech, and we have a showcase also in our booth that shows from Taktotech devices we can recycle polycarbonate very efficiently, and this basically also allow us to have device internals to be recyclable. So this brings the circularity to devices. But I would like to invite you to our booth to see some showcases. I think this is pretty much it, if I see the questions. Yeah? Thank you very much, everyone. Hope to see you again in our booth.